So let us discuss a question on strength of materials. Here we have a simply supported beam where we have a couple at the end. Now the question is we need to find out some statements are given about the bending moment and the shear moment. We need to find out. Okay, so what we do is we assume that this is entire length is L and this is couple M, and these are reactions R1 and R2. So let's first find out this so that we can easily draw shear force and bending moment diagram, and then we can check with the given statements. So now force balance will give R1 plus R2 0 because there is no external load. Now taking moment, let's say about point 1, point A, let's use what is given in the figure. So moment about A, we set it to 0. So mu is a couple, so it adds directly, and R2 into L is the anti-clockwise couple. So mu is clockwise, we take clockwise positive, R2 is anti-clockwise, R2 positive, R1 doesn't produce any couple because we are taking about moment about A. So R2 is mu by L, and we substitute, go back, we substitute in the first equation, we get R1 as minus mu by L. So in fact, so now if we put the reactions, this is mu by L and this is acting in the opposite direction, that's why we got minus mu by L, and this is the couple mu. So this is the complete loading diagram with the reactions. Okay, now the shear force value, as usual we start from the right side. Okay, and now we take only the right side, we take a section, the right side of this section we balance it, so you get, because the reaction is mu by L in the upward direction, so the shear force will be downward direction and it will be mu by L. So downward we represent in the bottom. It again depends on your sign convention. Okay, so we represent shear force which is downward, we represent in the negative direction, and now the concentrated movement doesn't affect any shear force. I mean this can be easily found out. Now till the right side it is mu by L, minus mu by L. If you take a section here and then balance the right side, only the force balance if you do. So this is mu by L and this is mu. So here even if you do the force balance, you will get the shear force as same as mu by L, because the force balance should be always there, and because of that if you find out the shear force, it has to be mu by L. So the shear force doesn't change along the length. Okay, only there is a change in the ends. So this is mu by L, even though it's negative. I mean it depends on the sign convention. Okay, so my sign convention is that take a section, start from the right side, take a section, if the shear force is coming downwards, represent it below the line, and so the value remains constant, mu by L. Okay, so based on this we can eliminate one thing. So R is correct, S is wrong. Okay, now about the bending moment. Now come about the bending moment. You take a section here. Okay, and if you take a section here, so let's balance that outside. So mu by L, so mu by L produces anti-clockwise moment, so you have to, the internal reaction has to be this way, right? And that M will be mu by L into whatever the length consider, that is X. So mu by L into X. So mu by L X, and this is a sagging bending moment. You can see this is a sagging bending moment. You take a point here, very small element here, you have a bending moment like this, and to balance it there will be right here. So it's a sagging bending moment, something which you get in a simply supported beam, and sagging by my convention, sign convention, I represent it above the line. So mu by L into X, when X is 0, you are starting from the right side, when X is 0, bending moment is 0, and it increases till you reach the couple point. So at that point the bending moment is mu by L, mu by 2, because mu by L into L by 2 at the mid of the span, just to the right side of your bending moment. Now if I take a section left now, so if I take a section just to the left of the bending moment, just to the left of couple. Okay, so here what, just to the left of couple, what is my bending moment? Now because of this reaction mu by L, the bending moment is mu by L into L by 2, which is anti-clockwise, and plus U is clockwise. So the effect is that plus u is clockwise, this is anti-clockwise, so effectively you get mu by 2 clockwise, and hence it has to be anti-clockwise. So the direction, there is a change. On the right side there was the bending moment was all, bending moment is the internal reaction of one part of the beam on the other part. So on the just on the right side of the couple, the bending moment was clockwise. Okay, it was sagging bending moment. Just to the left of mu, it becomes a hogging, something like this. The bending moment is something like this. It becomes a hogging bending moment. Okay, and therefore we represent it downwards. The value is mu by 2. So there is a sudden change in the bending moment, mu by 2, and thereafter, as you take a section towards the left of towards the left, it will start decreasing, and at the end it has to be 0. Okay, at the end, because these are hinge joints. Okay, so they don't support any, it's not a fixed wall, so at the end of the hinge joint it has to be 0. So you can see that when you have a concentrated load, you get a change in the shear force diagram. When you have a concentrated movement, you get a change, sudden change in the bending moment diagram. Okay, so here we had the second case where there was a sudden change, where there is a concentrated movement, and so there is a, so you don't feel anything on the shear force diagram, but you feel a sudden change in the bending moment diagram. Okay, so this is something which you have to keep in mind. So the bending moment is constant, so Q is wrong. Bending moment is 0 at the ends and maximum at the center. Yeah, it's maximum at the center because in fact it's maximum and there's a sudden change. So maximum, I would say it's mu by 2, and then there's a sudden change in the sign. So P is correct. So P and R go together, they are correct. So C is the answer. Thank you.